Hello everyone, this is the environmental science content video for Unit 4, Section 3. We're going to talk about how the human population has changed, specifically within the past 1,000 years and within the past 200 years. All right, so we just finished talking about populations in general. Now we're going to just be a little bit more specific and talk about the human population because we're all humans. And if you're not, let me know. So, demography is the study of populations over time. You might have heard the term demographics before, which is the breakdown of a population in terms of what kinds of things they are. And demographics is a whole nother spiel, so we're not going to delve too much into that. But the general growth of the human population for the past 1,000 years fits right here on this graph in this bottom below my face. Right in the Middle Ages and what we call the modern age, it has been exponential. And generally, before that, the human population was very, very low. Going as far back as history shows us, it's been very, very low until right after the bubonic plague dropped our species because about a third of the species died in some locations. We came out of the Middle Ages. And when the Middle Ages ended, a lot of things changed. We had a large change in the way that science and knowledge was viewed, as well as how the working class versus the ruling classes were viewed. You can ask your history teachers about those. I'm not doing that. I'm a science teacher. And then modernization occurred. The Industrial Revolution happened, and it didn't take as many man hours to create something. Automation started happening. And that meant humans could afford to work less and have more leisure time. It also meant that it was cheaper to have more kids. And if it's cheaper to have more kids, that means you can afford to have more kids. And we'll talk a little bit more about that as we get through this. All right. So here's a general graph of the human population, and you can see the color changes coincide with the brackets at the top, the Stone Age versus the Bronze and Iron Age, and the Middle Age and Modern Age, which might be covered by my face, but those are the blue and the green. So you can see that the population drastically skyrockets. And here's the thing about exponential change like this. The bigger the population is, the more kids they can have, which means the population that comes after them is going to be even bigger, and so on and so forth. So in your head, just do 2 times 2, you get 4, right? 4 times 2 gets to 8. 8 times 2 gets to 16. 16 times 2, 32. 32 times 2, 64. 64 times 2 gets you to 128. And this keeps going over and over again, right? But we're doing this on a generational scale. So that's just if every one person has 2 kids. So if every family has 4 kids, right? Because it takes a mom and a dad to have offspring for humans, right? One of the other things that demography looks at is the breakdown of a population in terms of age and gender. Now, females have more of an impact on the species continuing population because they're the ones that give birth, right? Guys were there at the beginning, and then after that, we don't really matter in the terms of raising kids or having kids. So females are generally looked at more important for how a actual population is going to continue. And so we're going to look at these age structure graphs to show who is in a reproductive year, so if they're likely to have kids or not, who isn't likely to have kids or not, and who is a kid themselves, because they're going to be transitioning into those reproductive years as time progresses. And using these, we've got 3 different types of population structures that we'll see. All right. So rapid growth looks like this on the side here. And we've got this conical structure where there's not a whole lot of older individuals, but there's a lot of younger individuals. Those in their reproductive years are far outnumbered by those in the pre reproductive years. This occurs generally in lower developed countries because of high mortality rates of younger people and infants. Right? But as that nation continues to be more and more developed and is transition, we call it a transitional nation or a transition nation or a growing population. That curve is going to get flatter. So it's still going to be kind of a cone or a pyramid, but we're going to see smoother lines here as there are less and less younger people dying and able to move into those reproductive years and have kids. It also means more people are growing to live longer, right? A zero growth or a declining growth population looks more like this, where there are a lot of individuals in their reproductive years, but there are less people pre-reproductive years. So they're having less kids, right? But we also have a larger, older generation. So compare this one, 80 plus, there's barely any there. Still almost nothing, but this is a much larger percentage of the population, all right? Remember, that's the x-axis down here. Percent of population, age is on the y-axis. Pretty easy to read these. So the larger the amount of individuals in their reproductive years, the more likely that a nation will be closer to a developed nation. I'm going to use air quotes there because it gets a little tricky in how you actually classify a nation as developed or not. We're not going to go into that. We're a high school level class. Right? But we can use a few different factors to actually inform what we think the population will do. So age structure is one of them. Survivorship is another. So how likely are they to continue surviving and reproducing versus dying? Now, we usually think of this as, dying to diseases or not having enough food, but it could also be that there's a war going on and a bunch of men ages 18 to 35 to 40 even die all at once because of a war that happens. This affects the survivorship, right? In today's age, especially in America at least, women are also fighting on the front lines, and that affects survivorship even further because women have a larger impact. All right, fertility rate is a way to calculate the amount of people that are likely to be born, right? And we're going to do that and use it to calculate something called a total fertility rate, which is the average number of children a woman gives birth to in her total lifetime. So fertility rate is just per year, so how many kids per year. For humans, that's generally one or less than that because it takes 9 months of gestation before birth. That means you're pregnant for 9 years. Right? But total fertility rate is like, yeah, you might have one kid 1 year, but the next year you might not have any. So it's going to be lower than one over the span of a lifetime. Now, migration is the movement of a species, right? So we've got two words for human migration, and we kind of use these for other species as well, but we're talking humans here. Immigration is into an area, immigration is out of an area. Yes, those sound exactly the same. I am sorry for how terrible English is, but luckily we can write them down. So immigration with an I, think of like into or entrance. They both start with I. Immigration with an E is like exit, leaving, right? That's the only way to break that down. And when I use those words, I'm going to try to either have them written or I'm going to say immigration with an I or immigration with an E, or hopefully you can at least get it from the context of the sentence. Right? Life expectancy is how long an individual is expected to live. It is very similar to survivorship, but it is going to be that the longer the lifespan of an individual, the more kids they're able to have, the larger impact they will have on the overall population, and they may even become a burden to the population if there are a lot of individuals who are older and need taken care of but cannot work. The other thing that is seen with life expectancy is that the older an individual is, the more likely they are to suffer from a communicable disease, because once they get it, their own immune system is more taxed and has declined because of their age, and it's harder for them to fight it off. Right? And I know this is another big graph. We'll break it down. It'll make sense. All right, so let's start at the bottom. X-axis is time. Farther that way is towards the beginning of time. Farther this way is towards the future. All right? Easy. Vertically, we've got two different x-axes on the same graph, and this gets a little weird, I know. So look at the left one, right? The one over there. Sorry, my camera's mirrored, and I'm trying to make sure I'm pointing the right direction. The one on that side is birth rate and death rate. So how fast individuals are being born and how fast individuals are dying. The one on that side is population size. And you'll note that the slower individuals are being born and the slower that they're dying, the lower the population in general. The higher birth rates and higher death rates occur in larger populations because there's more people to give birth and there are more people that can pass away. It makes sense? So we're going to treat those as the same, although generally population size is going to be much bigger than the birth rate and death rate, unless you use a percentage, which is what we did here with this graph. So the stage one here is pre-industrial. So before the Industrial Revolution, before machines, before being able to automate some things, we see these different lines kind of tangled in a mess, right? So this blue line is population size. So we can see here, population size, real low, right? Very small. The orange line is the death rate. So sometimes the death rate is lower, sometimes the death rate is higher. It goes back and forth, right? Birth rate, again, is that green line. Sometimes it's lower, sometimes it's higher than death rate. No matter what, they are higher than this yellow dashed line. This yellow dashed line is something called the replacement level birth rate. That means you're having enough kids to replace you. So if there are two individuals that are going to have kids, a male and a female, and they have two kids, one male, one female, or at least enough that if everyone is doing it, it averages out to be 1:1. Sometimes this can get like 60-40 ratio and it'll still be okay long term because of the law of averages. As time progresses, this community moves towards a transitional stage where we're moving towards an industrial stage, but we're not there yet. Right? So population is continuing to increase while birth rate starts to remain constant, but death rate goes down. This is generally due to either increase in safety factors, so people are less likely to die in their day-to-day lives. Healthcare increases, so if they do get sick, they're able to get better and recover, and a decrease in infant mortality. Right? As that continues to happen, the birth rate goes down as the population size increases. Right? As the birth rate heads towards the replacement level birth rate and continues to decline, the population increases. And this is that industrial and post-industrial levels here, right? So once the birth rate is at the same level as the replacement level birth rate, that is usually a hallmark of a post-industrial society, and the death rate is going to continue to be lower, right? Because the birth rate goes below the replacement level birth rate, we see the population size, this blue line, start to go down again, right? And we don't really know where this is going to go. There are scientists whose jobs are to forecast populations. They are demographers. But this is a high school level class, and we're not going to get too in depth here. So we're just going to talk about what we know rather than what we think might happen after a post industrial society. My 2 cents, eventually this birth rate is going to go back up, and this blue line is going to continue to go back up as well. Death rate will usually stay really low, though. All right. I know this is usually the slide I end on, but I want to talk a little bit about the impact on women to the overall population size because it's important. So, what we've seen is that the impact of women, because they are the ones that give birth and generally are tasked with child rearing, the fertility rates, and so how often women have children, is highly impacted by the economic independence of women and the education of the women in a society. So, as more and more women enter a workforce, they are less likely to have more kids. The more likely they are to have more kids is tied to them being a stay at home mom, effectively, or that's what we would call it here in America. Now, we're sticking with science, so ethics isn't a concern here, right? But generally, families that have more kids, those kids are able to either A, work and actually help provide for the family unit itself, or B, can help take care of the even younger children, or C, can help take care of the elderly. All right. The more children that a family has, the more likely it is that those children are going to be able to take care of the elderly in the family. And as a population changes to be having that more traditional and zero growth, we did see that age structure get bigger and bigger, right? More elderly folks. So there is an upside to having more kids, but those kids also cost money, and money is a limited resource. So you may not be able to afford to have many kids. It is a balancing act. And like I said, we're in science. So we're not going to say what's good or bad. We're just going to say, hey, this is what happens. The longer that a woman is in the reproductive years, the more kids that they're able to have, the larger the impact that they will have on a population size. And remember, we're not talking about individual women here, we're talking about all women in a population. All right, so how has the human population changed within the past 1,000 years? It's grown exponentially. In the past 200 years, we have seen a slight slowdown in population growth in our more developed countries, but the overall human population, Earth's population, has continued to rise exponentially. Right? Remember, if you're one of my students and you're watching this video, if you've got questions, put them in the forum, send me an email, reach out. I can talk with you. Use my office hours. Have a good day.